Okay, so today we are moving to solving logarithmic equation. In the last lesson, we did solving exponential equation. So to solve logarithmic equation, we are going to have to either go to the exponential, or we're going to have to use the log laws to logarithm law to solve. Or if we have the same log on both sides, we can ignore the log and then or drop the log and then solve. So there's multiple ways to solve a logarithm. It all depends on how the equation is set up. So solve the equation log x plus 5 equals to 2 log x minus 1. So if you're looking at this one, you have log on both sides, but the problem is I have that 2 here. So I have to get rid of that 2. And to get rid of that 2, I can apply the power law of logarithm, right? And then bring that 2 up to the exponent. So you'll have log of x plus 5 equals to log of x minus 1 squared. And then if I have the log of the same base on both sides, then the log drops, and then you'll have a is equal to b. This is one of the laws. And then this is what I have here. It's log base 10 for both of them. So I can drop the log, and then I will have x plus 5 equal to x minus 1 squared. I can expand this bring everything to one side and collect like terms. So if I bring the x over, it's going to become negative x, so I'll have negative 3x, and I have 1 minus 5, so that's negative 4 equals 0. I'm looking for two numbers. I multiply to negative 4 and add to negative 1, so that's going to be 4 and negative 1. So that's going to be x plus 4, x minus 4, and then x plus 1. So therefore x equals 4 and x equals negative 1. We're going to reject x equals negative 1 because if I take negative 1 and put here, that's going to give me negative 1 minus 1, which is log of 0, and I can't take the log of 0. It's undefined, so we're going to reject x equal negative 1 because log of x minus 1 at x equals negative 1 would be undefined. All right, so you always have to look at your final answer, and then you're going to have to make sure that your final answer holds true or is appropriate and satisfies the equation. The second question is solve simple logarithmic equation. So in this case, to complete this lesson, you will need to remember how to change from logarithm to exponential. And remember that if I have it in logarithm form, y equals log base bx, it will become as base b to the power of y equals to x. So remember that that base becomes the base of the exponent to the power of y equals to x. So if I'm going to solve this, this is a base 10 here. So I can rewrite in exponential form. And then that will be 10 to the power of 1 equals x plus 4. So I wrote it in exponential form. Bring the 4 over. So 10 minus 4 equals to x. And x equals 6. And that would be my solution. Another would be if I can write both of them. Another way is if I can write both sides as a logarithm of the same base. So since this is a base 10, then I'm going to write this side as log base 10 as well. And to get 1, it's going to be log base 10 of 10, right? Because that would give me log base 10, 10, that would give me 1. So I can do that. And then because of the same, so back to the first question, I have log on both equalities, and then it's the same base. So right away that makes it, I can drop the log, and that makes it x plus 4 equals 10. and then x equals 10 minus 4, which is 6. Whatever is easier for you, you can follow. I personally like to rewrite as an exponential form. So I have log base 5 of 2x minus 3 equals 2. So the easiest way to do here is to write it as an exponential form. So that's going to be 5 to the power of 2 equals to 2x minus 3. So 2x minus 3 equals to 25. And then 2x equals 25 plus 3, which is 28. Divide by 2. And that would give me x equals 14. So solve each equation and reject any extraneous roots. So what I have here is I have log x minus 1, take away 1 equals negative log of x plus 1. So there's no way for me to drop the log on both sides or anything like that, because as you can see, I have that negative 1 here. So what I have to do, and what's the best way to do, is put the logs on both sides, on the same side, sorry. So that would be log of x minus 1. And then bring that negative log over, so it's going to become plus log of x plus 2. And then bring that negative 1 over as a 1. And the reason for that, if you see here, what I will do is I'll put them as the 1 log using the product law. And that I can solve, right? That's the only way I can do this. I need to have 1 log. So in order for me to do that, I can do log of x minus 1 times x plus 2, because there's an addition here. And as you can see now, it's 1 log. It's similar to the questions that we've done before. I can rewrite it as an exponential form. So that's going to become x minus 1 times x plus 2 equals to 10 to the power of 1, which is just 10. I can expand minus x plus x, so that's plus x, plus 2x. That's going to be plus x minus 2 equals 10. Bring the 10 over, so that's going to be x squared plus x minus 12 equals 0. So that's x plus 4 and x minus 3. Because I'm looking for 2 numbers, I multiply to negative 12 and add to 1. And that will give me that x is equal to negative 4 and x is equal to 3. If I plug in negative 4 here, that's going to be a negative. If I plug in negative 4 here, that's going to be a negative. So I have to drop that. I have to reject the x equals negative 4, because that is going to give me an extraneous cases, and it's going to be an unidentified value. So the only solution I have is x equals 3. So remember that because when I plug in log negative 4 into any of these logs, if I plug it in negative 4 plus 2, let's say, that's going to give me log of negative 2, and log of negative 2 is undefined, right? So that's why I have to get rid of that answer. All right, what do we have here? So we have log of the cube root of x squared plus 48, x equals to 2 over 3. How would we want to do this? So there's different ways that we can do this, but I think the best way is to get rid of the cube root first. And to get rid of the cube root, I'm going to write it as log of x squared plus 48x and then to the power of 1/3. And then if I bring that 1/3 over here, and what I can do here is I can get rid of that 1/3, so I can bring the 1/3 over as a multiplication by 3, right? So that's going to be log of x squared plus 48x equals to 2/3 times 3, which is 2. And then you see now it's like similar to what we've done before, so it's going to be x squared plus 48x equals to 10 to the power of 2, which is 100. Bring the 100 over, so x squared plus 48x minus 100 equals 0. And we'll multiply to negative 100 and add to 48. So that could be x plus 50 and x minus 2. And that would be x equals to negative 50 and x equals to 2. And then if I go back here, if I have negative 50, that's going to give me, let's see. So if I have negative 50, that's going to be a big number and it's going to be positive. And so you plug it in, right? So you have to plug it in. You don't just assume that because it's negative, that means it doesn't work. That's not right. Okay. Times negative 50. So basically, if I plug in negative 50 into here, it's going to give me 100. So that's a positive. That works. And if I plug in a positive 2, that's going to work. That's going to give me a positive number. So both of them work. And then both cases are acceptable. So I have to keep both answers. All right, in this case, I have log base 3x minus log base 3x minus 4. Both have the same base log. There's a minus between them, so I can write them as one log, and then it's going to become x over x minus 4 equals 2. So you see right now, I have one log, so I can write it as an exponential form. So I have x over x minus 4 equals to 3 to the power of 2, which is 9. I can bring this over here, the x minus 4, and it's going to become 9 times x minus 4. And then bring everything to one side. And then solve for x. And then 9 over 2, it's a positive number. If I plug it in both, that's going to give me a positive answer, and I'm good to go. All right. So if log base AB is equal to 3, then use log rules to find the value of log base A of AB squared. All right. So I have log base A of B is equal to 3. So I can't use it unless I look at this and see, okay, what am I going to do with this? So I see that there's a multiplication between A and the B squared. So I'm probably going to write it as log base A of A, and then plus log base A of B squared. I'm going to try to make it similar to this because then I can replace it with a 3. So that's going to be log base AA plus 2 log base A of B. So you see now this is similar to what we have here. So I can replace it with a 3. Log base A of A is 1 because it has the same base, plus 2 times 3. So that's going to be 7. So remember that if I have log base BM, it's the same thing as writing it as log m over log b. So this one, because it's log base b and I want log base ab, so the other way, I can rewrite this as log base a of a over log base a of b. So instead of making it as base 10, I can write it as base a. Okay, so here usually it's a base 10, but what I did is I made it as log base a because what I want this to be 1. So that's going to be 1 over, and like log base a of b is 3, so the answer is 1 over